Hi everyone, my name is Matthew Meron. I work as a cloud solution architect for Google. And today we're going to see how Airbus scales workers and pool of workers for processing satellite images. I am today with Laurent Gabet, the optical R&D manager for Airbus. And we're going to switch to present you all those slides and do some demos. So Laurent is going to start by introducing a little bit about how Airbus decided to move to the cloud, show you a couple of workflows for image processing. Then I will take over to actually explain a few concepts of Compute Engine and Google Cloud Platform, and then discuss a little bit what kind of implementations were done by Airbus. And in the end, we will talk about next step for Airbus and also for you if you want to get started on Google Cloud. So for now, Laurent is going to get started.
Okay, hello everybody, good afternoon. So I'm glad to be here with you in this impressive Google Cloud event. So I will provide you today, during this 1 hour, a testimony of how within Airbus Defence and Intelligence we move from our prem facility to a public cloud facility. So you will discover that it has been a quite challenging experience for us. So we will not start by that, but if you stay with us during this hour, normally thanks to all the details that Matthew will provide you, you should be able to implement such a workflow by yourself. So please stay in the room. Okay, so first, before starting, in order to understand the presentation, you should know who is Airbus Defence and Space Intelligence. It's a business unit of Airbus, the well-known brand. I guess that you already flew with an Airbus aircraft. So we have four pillars in our activity. Two ones on the left, satellite imagery. And solution and services based on those satellite imagery. So we will dig this subject today, and two other subjects focusing on defense applications, so intelligence, so AI, as we have seen, is a key issue for this topic, and a complex operational mission planning for defense. So let's start the presentation. So here we have our own satellite Earth observation satellite Constellation. So we have today in the air 7 satellites. 5 of them are optical, and 2 of them are radar. So the 2 main flagships in this constellation are the Spot satellites and the Pleiades satellites, and the 2 radar satellites that you see here on the right are quite well known because we built the mapping in 3D of all the Earth in once with those interferometric engines. So it provides the best and more accurate 3D mapping of the Earth. So let's start from a long time ago. So 30 years ago, we launched our first satellites, which was Spot 1. And it was the first civilian satellite with stereoscopic capabilities, so enabling the 3D capacity. So since all of our satellites are able to provide the 3D processing of the Earth, which is quite important nowadays because 3D is a key feature. So 30 years ago, we were already digital, as you can see. Some of you may remember this time, but most of people in this room are younger than 30 years old, so they have not noticed that. You may see that we were already fashioned by the time wearing a beer. So. And we were doing our best to satisfy our customer and having a map of the Earth and planning the satellite shape on the Earth. So that was quite challenging by the time. We were not yet object storage, so putting an image in the object storage was not as efficient. So here it was tape. So we had to remove the tape, to put back the tape, to get the image, etc. So it was an interesting, but everything was digital, and at this time we were very proud of that. Our main competitor by the time was a Russian company, a Russian satellite, and they were analog satellites. So it was we were very proud of that. It was taking days and weeks to get an image. And even the image, the sensor were digital, but the key issue by the time was to get to the customers a good printing shot of those images on a very strong paper, because most of our customers were not digital by the time. They were analog, and those images were pushed on their analog stereoplotter in order to do their mapping. Okay, we improved years after years, and now we are providing in a digital form to our customer digital imagery, nice ones with nice colors, as you can see. It was ours. I say in the past it was, because now we're on the cloud, so we are not ours anymore. But it's still the same images. Okay, so we moved to the cloud, and I will describe you what it means for us to move in the cloud, to the cloud. But for us, it has been a major step toward efficiently. So here we have now we are able now all of our images are on the cloud, and we are able to access them within a time frame of half a second. It's we can have unlimited users. The platform can host an unlimited number of images. It's worldwide. This morning, it has been. Eric Schmidt said that the good thing with the Google network is that you can access to the data everywhere in the world, and it's really true. It's really true for us. We are using this functionality, and our customers are very well served. Today, we are storing a part of our images. We are not at a full power, because we are waiting a little bit to see how things are going on. So it's half of our capacities, of our satellite capacities, and it represents half a petabyte per year, roughly. We are currently developing building our next Constellation satellites, which will be far more accurate, far more precise, with a larger efficiency, and we will be at a rhythm of 2 petabytes a year. So our satellites are directly connected to the cloud, and we are feeding the cloud at a rhythm of 2 million of square kilometers per week. So it represents roughly 4 times the surface of Spain per week. So a few words about the process. So before deciding to go to the cloud, we had to pick the right cloud for us. So we went through an RFP. So we are in an Airbus company. I mean, you have to go such things, and so it was seven cloud providers provided their feedback, and obviously we pick Google. For the main reasons, I could highlight some of them. First one, there was a commitment of Google that they will support us bringing to life our system and being successful. They did it. I have to admit that they have been very efficient doing that, and the best is that we are presenting together with Mathieu. So Mathieu helped us a lot during this process. Another point is that security, as we have all heard this morning with HSBC and the others going to the cloud, security is the major issue. So Google do have the right features for us. And other point is about the roadmap. In their roadmap, we were very interested by AI, machine learning. So it was already disclosed when we signed our contract, because for us, AI, machine learning is very crucial in order to extract automatically information from our images. So we pick Google and we start implemented our system on the cloud platform. So it's about the first step was about to connect our satellites to the cloud. So we have beams around the Earth, and we have our satellite flying over them. And when they have images, they are just downloading those images. And we develop internally all the connection in order to have a fully automatic process from the satellite up to we call it the Intelligence digital platform on the Google Cloud platform. So we uploaded all of our images on the object storage. And when we do that, in the same time, so we need to do some processing in order to prepare them to be easily accessible and rapidly accessible, to georeference them, to adjust them in order to be fully cartographic. So this is done in the cloud infrastructure. Then last year, end of September last year, based on the platform, we opened our first service, which is One Atlas. So you are welcome to subscribe to it for a fee. It's not free, but we open the first service, so it gives access to our catalog of data and images which are just sitting there to be used. I will provide you a real-time demo just right after this slide. And we are working, and we have already developed new services, solution, fully developed native cloud. So we went through the process that Eric Schmidt described this morning. I mean, the first process is you can take your code and you put your code, your 30 years old code or whatever, and you put your code as it is on the VM. You can do that. But when you are doing that, especially for remote sensing, image processing, you are not using the best of the elasticity and capacity of the cloud. So we had to redevelop not most, but a part of our processing in order to have stateless processes, and in order to use fully the elasticity of the cloud. So we have developed that, and we have a few solutions, and I will introduce just after the first workflow, the workflow that we implemented in order to do a very high-end processing. So certainly we are also on the analytics. We are working now on AI, as it has been introduced this morning. We are using TensorFlow, so we put it by ourselves, or we are using now ML, and we have the ability today automatically to extract all the clouds which are in the images, the planes which are in the images, a key subject for us, and we are starting. Few other subjects which are quite confidential for the time being. Few words about how an industrial company such Airbus is the difficulty to go to the cloud, to the public cloud. And I'll summarize that in 3 points. So security, I already described that a little bit. So this morning, HSBC said I was quite impressed, because they said that in 6 months they were on the public cloud. And in fact, for us, it took us 6 months just to do the paperwork and to get the stamp and the clearance from our security team, and because it's our first attempt to go to the public cloud. So now it will be faster, certainly. But so this process basically took us around 1 year. So another key point for a standard industrial company is the cloud technologies. So we have a very talented engineer in the company. They are able to fly rockets, to build satellites, to create optics, whatever. But the cloud technology are not yet there. And it can go very fast, but it's not sitting there. So we have to go step by step in order to increase the team which do have the knowledge. And also it's so fast, and that it can be an issue, and we don't know how we will deal with that in the future. But it's so fast that as soon as you have done something, in a way, it's already old. And there is something new. And then, so what I will describe today, it's something that we did 6 months ago, but we are already working on the next step, which is using Kubernetes, the containers, and not the VM anymore. So we are already changing our way to do things. So it's a kind of a difficulty for industrial company. And the other point is our goal is to be in operation. So as I don't know who said that this morning, but it's very, very difficult for a company like us, which is used to do something that should be right, and there is no failure like an aircraft, to a world where you should be prepared for any failure and react. So it's a different mindset, and our operation team, which makes sure that everything is working 24 hours by 7, has to get used to that and has to be prepared and all of that. So that's another difficulty for us, is to move to operation. So let's go to the demo. Okay, so that's our product. So it's One Atlas. So here we have just a small page in order to introduce our dataset. So you can go anywhere in the world. So you can go in Asia, in Australia, by example, and you can zoom in. And you will see that all step by step, you will see the details of all the images that are there. So here you see the set of images, and when you zoom in, you can see all the pile of images. So here we have a kind of a mosaic, but in fact it's the latest images that are visible, and an image is showing up every 3 minutes in the cloud, and is updating this mosaic every 3 minutes. So let's go to San Francisco, by example. I don't know why. Okay. No, it's San Jose, so I don't know. San Jose is not that. Let's go try to see the Moscone. Okay. Okay, here we go. Okay, so it goes to San Francisco. So you can see that it's quite fast. The access to those images is done for the B2B market. So the customer which are buying a subscription are using those images in order to do mapping activities, cartography activities, and they are plugging those images in their home cartographic engines. So a user which is in India or wherever, he should not wait for more than 1 second to get the imagery in order not to slow down its job. So let's where is the Moscone? So the Moscone is somewhere. Yeah, I think that's the one. So you can zoom in and you can see the Moscone, which is here. So you can turn around, and on this part, if I zoom out, on San Francisco. Here, what you have here are all the images. What you see here are all the images which are available on this area. So we can see that we have a Pleiad. A set of Pleiads of May 1st, then we have a Pleiad of April, so March 16, September, June. Okay, so all of those images which are acquired by the satellites are piled in the catalog, and we are introducing for an easy access this mosaic. So if we can go. If one key feature is if we see those images are prepared by our system, so they are fully aligned in order for. So you can see that there is two different images here, but they are fully aligned in our internal processing engine in order to make sure that the cartographer which are using them properly and provide a accurate result. So what our customers are using, it's certainly not this tool. It's the URL. In fact, all the output of our system are normalized according to OGC standard. So you can see here you have a WMS service. So you can copy paste this URL and you can plug in your professional tool and start doing your work with your process, with your habits, with all of that. You don't have to mess with our tool. You just are accessing to the data through the cloud system. So that's basically the functionality. So let's we can have a look to another area, and then I will jump to the complex. So I think San Diego was quite nice too. So let's have a look to San Diego. Okay, so in San Diego, here we are. It's quite a desert area, so it was it's always nice to look at and you can see that the pile of images is impressive. Yeah, I just removed the background, but here. Okay, so another point with this system is that there is, as you may have noticed, there is no he is showing each image individually at this point. So that was. What is in this system, what is impressive is there is no cloud. So when you are shooting the Earth from the sky using the satellite, it's a big mess of cloud, in fact. And our duty for our customers is to remove the cloud to get the best images without cloud. So when you pan around and you take each image, there is a minimum cloud. Here there is an image with cloud, but we don't care. It's on the ocean. Okay, so if we can go back to the presentation. Okay, so now let's do the hard work and let's try to analyze what is a complex workflow and how to implement a complex workflow of image processing on the cloud. So don't be scared, we will not analyze that accurately, just to provide you an example. This should work, okay. Okay, so it starts there, and it's ending. Yeah, it's ending somewhere at the end backside. So what is important for us, and I guess important for everybody and for you, is that we should not pay anything to Google Cloud when there is no actions, and that's what is happening here in such a workflow. So when we have no activity, we should have no compute. So here, this is the beginning of the workflow, and in this case, it's a front end, and you have an operator. The objective of this workflow is to update the database with the freshest images that show up in the catalog or which are available on the cloud, free data like Sentinel-2, Modis, and Landsat. So he said, let's start updating the database. And when it provided this order, it uploaded a message on a PubSub queue. And the PubSub queue is set up in a way that it will awake a processing which is on AppEngine. So that's the way it starts. And then this processing create a compute, and the compute will prepare the database, will prepare the update that is required. So we'll look for all the new images which are available on this area of interest, prepare the parameters, okay, prepare all of. So then he ends with a conclusion that I have so many images to analyze in order to update a complex database. And in most of our analyses, each image has to be scanned one after the other in order to extract information, and then this information is crossed with another information, the other images, etc., and then in order to provide the final result. So this engine is putting for each image in a pub/sub queue a message like process this image. So here we are ending in this BP pub/sub queue with a list of hundreds and hundreds of images to be processed. So same way, the pub/sub wake up a tool which is sitting on Nginx, and then this one through the autoscaling that Mathieu will describe later on. Through the autoscaling system, will create as many compute as required in order to do the process. When it's done, they are reporting it's done, updating the database, and the next one, the next process could start, and so forth up to the end. So that's a specific workflow for remote sensing, image processing. Most of the time, a remote sensing processing could take from few minutes to an hour or 2 hours. So it's not a standard web processing. It's most of the time long processing. So then let me show you that. So if we can switch to the video again. Okay, so here that's the visualization of the workflow that I have introduced previously. So as you can see, each line corresponds to a processing, basically a compute. So we saw that it has been from 0 compute, it went up to as many compute there in order to do the first task. So we have this tool in order which is reporting on the activity. So, by example, this process is processing this image. It took 740 seconds to do the result, and is delivering the result to the database. And when all of those are done, it can start a new process. And the new process is another process. But when I was telling you that images from the sky are quite a mess, and that's an example. So here it's very cloudy. You cannot basically get anything from this image. But as you have many images, you are able to end with a result. So step by step, we scale up, we scale down, we auto scale up, and that's another step where we have been able to extract a piece of information on this image, on this part. This image is a MODIS image. It's a NASA image, but you can have NASA. We have our own image in this pile also, and step by step it goes to the process. So then we have a kind of summary of the result, and we are ending with the result, and you can see, okay, it was in France. So it's kind of joke, but here, from all of those images which were very cloudy, that's the statistic. It's about vegetation information. That was the purpose of this process, which is updated at a certain point of that in the year. And the beauty of the cloud system, the autoscaling cloud system, which has been defined, is here we run it for the demo for France. So it took sometimes, I don't know how many hours, but maybe 3 to 4 hours altogether. But without any effort, we can run it at the Earth scale. And so it will auto-scale at the right size in order to make it happen. So that's for us a key point when we are developing a new service natively on the cloud. The scalability capacities are native, and you can run it in France, but you can in another world. When we are updating the mosaic worldwide, the mosaic I show you in one atlas, it takes us 48 hours to use all the images which are available worldwide, and during with using 200 computers. We could use more, but for us, having the mosaic done in 2 days was acceptable. So we capped the number of computes at 200. Okay, so I'm done for my part. So now Mathieu will introduce you what has been developed in Google and the way in Airbus we use it.
Cool. Thanks, Laurent. So I'm going to start by explaining a few Google Cloud Platform concepts and to be able to actually scale instances. So the first concept that we have are actually regions and zones. So we have data centers, Google data centers in different locations in the world, and we call them regions. So you can see here like some of them. We are working on expanding them during this year. The region is usually, there are several regions in a continent, and then within a region you will have at least 2 zones, but even more to set up things such as like high availability, load overflowing, etc. So in the zone, what you can do is actually run some tasks, but you need to kind of understand what sort of task you need to run. And those tasks have like usage patterns. So if you look at those patterns, there are like 2 most common ones. One is about it's unpredictable. So if you actually run, let's say, a website, so for example, when you create a website to show images of Earth, or if you run a website for like ticketing system, you might actually have a bunch of users that actually arrive at the same time on the website, and you need to scale like in a second. It might be like 100,000 users, something like that, and you cannot predict that, right? So this is usually when you need an autoscaler. It's to actually be able to scale based on that unpredictable load. The second one is a bit more predictable. It's usually when you run a website, let's say, around the world, and then the US wake up, Europe and Asia go to bed, something like that. So if you look at your over a week or a month or like a few days, you actually see waves of traffic. And this is predictable, but it's also something you need to be able to scale. So in both cases, you have to be able to scale up and down. The reason is if you over-provision, you're going to spend a lot of money that you don't want to spend. And if you under-provision, usually like you have to have an SLA on your website or your application. So if you don't have enough machines, it's probably going to be down for a lot of the users. So I think we made the point that we actually need autoscaler, but you also need to understand what sort of autoscaler you want to run. So if we look at tasks, you can have like short tasks, for example, serving a website or creating thumbnails from images. So usually that takes about like milliseconds, usually milliseconds. Or you can have actually long processing tasks, such as transcoding videos or rendering or actually processing image satellite, for example. And those ones work differently, and this is when you're going to define, okay, how do I autoscale this? So this is what we're going to look at. But first, we need to understand the core component of running a task, which is an instance. This is the basics of Compute Engine. So with our instances, you can install like operating systems, startup scripts, you attach them to a network, firewall. So a lot of the sessions here are going to explain that. But one of the specificity of Compute Engine is that you can actually create custom VMs. So if you're not happy with the amount of CPU and memory that we give you as a set, you can actually increase or decrease some of them to create your own machine. And this is useful because you can actually fit to the performance that you think you need, or you can fit to the price that your CFO thinks you need. If you get it wrong, though, we can actually give you an advice as well. So we look at over the time using our own internal tools like machine learning, most likely. We can tell you, oh, I think here you might actually want to downgrade what you set up because you're spending too much money based on what you actually need. Or we can also say, look, you actually should spend more money and increase what you're using to improve the performance. This is usually what we call vertical scaling. So you have like an instance and you just make it stronger or you make it less strong. But it's not always like the best case, because if you actually want to process like gigabytes of images, or if you want to actually serve 1 million users, you can go with one huge computer, but there's only so much CPU and memory that you can actually put in a computer or in an instance. So one useful thing to do is actually do horizontal scaling, which is multiplying the amount of computers that you are using, which works for a lot of use cases. It doesn't work all the time. Sometimes you need a massive computer, but more and more, horizontal scaling is becoming the standard. So to do that in Compute Engine, you use Manage Instance Group, which is leveraging an instance template. It's like a little horse here. So the template, you can create it in different ways. You can actually set it up yourself, saying, like you did for an instance, I want that much CPU, that much memory, and this is going to be my template that I'm going to reuse. Or you can actually create or reuse an instance that you already had, and create an image from it, and from that image create a template. And another solution we have is actually to use containers. So if you actually set up a containers and like build it in Docker, for example, and push it to a registry, you can use that container to create a template. So a lot of different options. It depends on what you prefer and how you want to work. The thing is, now you got a template. So you can actually create an instance group. And that instance group can be regional, for example, like across different zones. So if you need high availability, or it can be on one zone as well. In that case, it's 2 zones. And it will be load balanced. So in front of it, you will be able to put a load balancer. We're going to look at that on the next slides, which help balancing the load. That's the name. And you're able to auto-scale it up and down depending on your need, but you will also be able to do some rolling updates. So if some days you're like, okay, I need a new code, or I need like a stronger instance or something, you will be able to automatically update the instance group. You will also be able to auto-heal instance. So if one is actually dying, you're able to replace it automatically by another one using the template. So let's go back to one of the concepts, the load balancer. So we have different load balancers that we offer as a service. We have like HTTP, HTTPS, TCP proxy, SSL/TLS proxy, or UDP, so different level on the networking stack. This one, for example, is an HTTP load balancer, which means like in that case, you will have an HTTP, so you get one global unique IP worldwide that you can plug your domain name to, for example. And behind the scene, it will connect to backend services with a bunch of little steps. And the backend services will be able to actually route a request to the right instance in the right zone if you have different zone, or even in the right region. You can do like session affinities and a lot of things like that. On the features of the managed instance group, so we saw some of them. You have like rolling update, which will apply a template to a number of instances at the same time. So you can define how many instances, but you are also able to pause if you need to double check a few things, and even roll back if you decided that you made a mistake. We do that sometimes in Google. Then you also have the auto healing, as we saw earlier, which is not the same as the load balance. So it's leveraging an health check, and the health check appears in 2 things. One is for the load balancer. So a load balancer uses that to check, okay, is that instance working? If it is, it's fine, I can route traffic to it. If not, I will just use another one. But the auto-healing use another one, which is, okay, if that instance is not fine and it's kind of not doing much, then I will just like kill that instance and replace it by another one. And again, it's using the group template. And the last one is the autoscaler that you can plug to it. So you can actually use different metrics. It can be based on CPU. It can be based on the load balancing load. It can be based on custom metrics that you have in the monitoring, so you can create your own. It can be queue-based, which we are going to look later, or it can be a combination of some of them depending on what you need. The autoscaler, just to explain a little bit on how it works. First, time-wise, it will actually look at on how your instances are behaving across like a 1-minute sliding window. So it will look at like across the whole fleet of instances in your instance group. Okay, how you doing CPU-wise, or how you doing metric-wise, basically. And then every 10 seconds, it will be able to say, okay, I need to scale up or I need to scale down based on that. And usually it takes about 30 seconds to actually have a VM up and running. It's also cross-zone, so if you actually have an instance group that is regional, you're going to be able to create, well, the autoscaler will be able to create instances itself and rebalance the work and failover automatically. And the last one is money, because everyone has a CFO somewhere. So we try to fit it as much as we can to like the minimum of instances that you need. We also enable you to scale down to 0. So if you don't need to process anything, well, you don't need an instance. And it's also leveraging the per minute pricing that we have in Google, which means if you are running an instance for 70 minutes, you're going to be charged for 70 minutes and not for 2 hours. So I'm going to do a little demo now. Hopefully that's going to work. And it's showing how to resize images on the fly. So if you're in ad tech, for example, or in certain verticals, you usually have like maybe a big image somewhere, and you don't want to create every single image for every single phone, every single tablet, every single desktop, and all that. So sometimes it's actually fast enough to actually just resize it on the fly. So I'm going to have my image set up on the image storage, Google Cloud Storage. It's going to be about a 5 megabyte image. Then I already pre-created a container, which is in our registry that you can access to in Google Cloud Platform. And the template will leverage that container to create to be leveraged to create an instance group that will be auto-scaled. And in front of that instance group, we're going to put a load balancer, so we can actually have one IP that is accessible by all the clients. So if we could switch to the demo, please. You better applause like this when we're done. Thanks. So this is cloud storage. It's a bucket, it's a folder, like you put a bunch of files in here. And then I have one image that is 5 megabytes, and this is pretty big when you can look at it. So actually loading this on like a tablet would be quite hard over 3G, right? So what we want to do is, and you can see here, like the file is actually 5 megabytes. So what we want to do is actually resize that on the fly. So what I did is creating an instance group, and I played a little bit with it yesterday, so you can see all the spike here, which is looking at the number of instances in blue and the CPU in green. So currently I have one instance, and if I actually go to that instance IP, I'll show you after I did that. I can actually display that image, and it will be resized on like a 450 width. I don't know if you can read that in the URL, but this is basically what it's doing. So it's resizing the picture on the fly, and you saw that it was quite fast. So now what I'm just going to do is actually load test this. It's called something called Vegeta, which can actually, in that case, call the URL 10 times per second for like a duration of 5 seconds. And it's using this URL, which doesn't have actually our same IP, because this was for one instance. It has our load balancer IP. Oops, maybe I didn't put the right one. Let me check. Should be this one. Maybe I didn't set up correctly. For some reason, I didn't set up the load balancer correctly, but we should still be able to actually have like the instance group automatically scaling. When I knew the, it's interesting. Okay, we might get back to it later. Oh, okay. So we can see here, like it took like a few seconds, but you can see that based on this, it's actually creating automatically several instances. And you can see in real time, you actually have like the number of instances that is changing. So we should see it appearing here based on the CPU that is required. And if more CPUs are required, then I will just launch more instances. If less CPU is required, it will just kill them, as you can see on what happened yesterday. You can see now it's using more actually, because it realizes like there was a lot of load really quickly. So if we could go back, sorry, to the slides. Thank you. So that was the little demo. It's actually using several things. The first one is Nginx, which has actually an image filtering that you can install. So this is more or less a default configuration that I changed myself. I put that setup into a container. So this is the Docker file to create a container, and then you can build it and upload it to our registry and leverage that registry to do several things. The first one is to actually create our instance template, and you can see it takes like a few lines. So I just open like the firewall for HTTP server, which means we can actually HTTP request the thing. I use the micro instance, so it's small, so I can show you the scaling. Then from that template, you can create an instance group. From that instance group, you say, OK, I want to use the template for it, and I want one instance in there. And I make it regional, which means I'm going to get automatically actually high availability and failover. And then that instance group, I will set up an autoscaler, which is going to be based on one instance at a maximum of 20, because CFO again. And then I want it to kick in when I have like an overall usage of my instance group of 60% of CPU. And then I give it a cooldown period of 90 seconds, which means like for the instances that are actually started, I'm just going to say for a minute 30, they shouldn't be taken into consideration in my autoscaling decisions. So this is more or less what I had to do to create the demo that I showed you. But actually, so that works fine because, as you saw, it takes a millisecond to resize that image. But in Airbus use case, when you actually have like huge satellite images that can take 10 minutes up to like a few hours to get processed, you actually don't want to kill an instance when it's almost being done processing an image after like a few hours, and you're like, OK, yeah, well, actually, we don't need you anymore, and you will have to reprocess. So there's a few things that you can put in place to actually prevent that. And one of them is to use a pub/sub-based autoscaler, which in that case, you will have on the left-hand side, you will put an image. Automatically, an AppEngine or Cloud function is going to look at, oh, there's a new image. Please change that and process it. So it will put that in Cloud pub/sub. And then a set of workers that you can see at the bottom is going to be auto-scaled, and one worker will just pick an image, process it, do whatever they have to do, and then save it back to cloud storage. To prevent instances to be killed while they're actually processing something, so I don't know if you can read, but there is something written CPU equal 1 and max backlog equal X, let's say like 3 images. So by combining the two, you actually scale on the size of the pub/sub and the queue, but you prevent instances that are working to get killed. And this is like a combination of those two parameters in your autoscaler prevent that from happening. In the next few slides, we're going to look at how Airbus implemented this. So they actually had like a couple of other ideas as well. And I wasn't supposed to present that, but Thomas, which you might have seen on the first slide, actually had a baby last weekend, so Basil. And so you're stuck with me for another 3 slides. So the requirements were a lot of the things that we already mentioned. Airbus needed near real-time processing, which means that they don't need images to be actually treated in real time, but they need to be treated as fast as possible. So you don't want the queue to basically wait for like 3 hours because you only have like 2 instances there. So you have to be able to scale up and down based on the size of the queue. Another one is like the jobs are actually irregular across the year and even like across the months or across the day. So sometimes like you might have to do like a mosaic that it's done yearly, or you might have to kick in like a job for agriculture, but you don't really know when it's happening. So when nothing is happening, you obviously don't want to have like any instance running because that might last for a few months. And when something is happening, you actually want to be able to start those instances. So they needed something to scale down to 0, which we actually mentioned before. And they have long-running processes. So as we said, like processing an image can take in between 10 minutes and a few hours. This is why you don't want to actually kill an instance that is processing something. Otherwise, well, the job is going to get back into the queue, and then you're going to have to wait for another few hours to process that image. And the last one is, what type of autoscaler do I need? We mentioned that earlier. So do I want an autoscaler based on a CPU? Do I want an autoscaler based on a custom metrics? Or do I actually want an autoscaler based on something else? So in that case, sometimes you have instances that actually are using no CPU but are waiting on I/O. So basically, most of the metrics that we had in standards didn't work. So you actually have to base that on the amount of images that are in the queue to be able to process. So those were the requirements, and they came up with a couple of ideas, or we came up with a couple of ideas. One of them was to actually use a gatekeeper, which is like a small little instance that will look at a queue, see when there is a new image coming, see if that image should actually be processed, and put that image metadata into a worker queue. And the workers will look at it. One is going to pick it up and say, OK, now I'm working. And every instance have metadata. So they say, I'm active. Don't do anything to me, please. And when in the same time, the gatekeeper will put in our data store, which is a fully managed NoSQL database, will say, OK, I have like an image being processed. And this is how I keep track of how many are being processed. And the worker, when they're done, will basically say, OK, that's it, I'm done. If you need to kill me, please do. I uploaded the image, and the gatekeeper will be able to look at the ratio of how many messages are in the queue and how many workers are leaving. And then based on that ratio, we'll be able to scale up or down. So this was one solution. The second solution that I set up is a little bit simpler. So you still have that worker queue. You still have like the autoscale number of workers. And then there is like a cron that is running every minute and actually use monitoring API from PubSub to check, OK, how many messages do I have in the queue that haven't been processed yet? And then based on that, and based on the worker that are working, I'm going to decide whether I need to scale up or down. So it's more like, it's not an event-based autoscaler. It's more like something that happens every minute based on the statistic that you get from our monitoring tool. So both are working. They've been implemented on like different projects depending on the need. So it's really up to you to see, OK, do I need something right away or do I need something like every minute? It depends on your processes. Or you can also use the PubSub as we mentioned earlier. This is an example of what is going on. So if we just look at the top two screens, you can see on the left how many jobs are needed, so how many images need to be processed. And then you can see on the right how many instances are actually working. So total CPU, if you see 800%, means there are actually 8 instances working. And you can see it's actually matching, like the both green lines, well, not really lines, but mountains are actually matching. So if you look at like 2 p.m., you can see there is an increase of how many jobs need to be processed. And you can see in the meantime, like the CPU is working and more instances are created. And if you look at the end, you don't need any image. It's actually at 0. And we also have like 0 instance on the right over there. And if you look at the worker CPU, so you can look at per worker, how's the CPU look like. The bottom line is our F1 micro, which was actually managing the autoscaler. So this is about it for like explaining a few concepts for autoscaling. Happy to answer questions after the session, but now we have like a couple of slides to explain what Airbus is going to do next and also how you can get started if you're interested.
Okay, thanks, Matthew. So for us, as a conclusion, so first of all, One Atlas, our first service, is available, so feel free to subscribe. We have started to develop our we call it the Intelligent Digital Platform. So it's our basic system that we are keep going developing, and which will enable us to develop new services based on analytics, to provide analytics based on ML, AI. So that's what we will continue to do. And we have an ecosystem, so we are developing functions and services where we are good at, but we are not good at everywhere. So we are welcoming partners that would like to join us to use our images or other images on our platform or on another platform, but accessing our dataset, our images through our API. So you are welcome to join us. And so now we are thinking of putting at scale. So we are currently uploading our current satellite imagery, but we have 30 million image satellites acquired since 1986, and we are considering to upload them in our catalog, and we are preparing also ourselves to welcome the new satellites which are being built now in the near future. So that's the conclusion for me, and maybe some next step for Google side.
Thanks. Yeah, I don't have much to say about this. You can read the slide, basically. But if you want to get started, please go to cloud.google.com. It's a good start. There's also a session if you're interested in learning more about how to deploy and update instances and work with Managed Instance Group tomorrow, I think. Yeah, it's tomorrow. And we have a little screen with a lot of architecture on every floor on this floor, and the fridge eye architecture as well with magnets. So if you need to talk to an architect, if you have like specific architecture needs, please come and meet us. It's on the 3rd floor, and the tree house is one screen where you can just touch and click, and you get a bunch of architectures out of it. So there's always one of us from my team to answer your questions. Thanks.
Okay, thanks.